Okay, hi again. Next example, and again, I would quickly hit pause and just write down the question. But basically, they're telling you they're parallel, and then prove they're parallel. They're telling you they're parallel. Therefore, you are allowed to. You're allowed to going to A. Told you to do. And then click on it. Therefore, they're going to the AB. You go to A minus 1. So therefore, if I multiply by 2 on this side, and then I add 1 to this side. So no way did I have to argue that they were equal. I could just make it because they were parallel line. Okay, you can always set an A and then check it. Don't worry about proving the grade. You know they have to. Again, I would do the exact same thing. I would work out. I think these are exactly the same. -4, -3, and -1, 3. Perfect. So just because of the fact that you really worked it out, gradients from C. That means the gradient from A to B. You could actually put the gradient from A to B times by 2 must equal -1 and try and solve for it. And use the trick. And the trick is if I know they're perpendicular, now they're the gradient. You have to show me working out or any reasoning. They told you they would change this. And what will be equal? -1 minus 2 over b minus -5. Now this becomes only slightly more difficult because the unknown is at the bottom. First is I would say I have, and I would multiply both sides by this b minus 5. So basically what's happening is we're multiplying this side by b plus 5. So that's cancel. Now what I see multiply. Then what I would do is I would divide this by minus 1. So if I just go here, let's get to 5, and minus 6, and minus 1. So in this one, we made a mistake. There we go. So the only reason now this is more difficult is that you had to flip the gradient around and change the sign, and then solving that equation was more difficult. But that's more of an equation than an analytical geometry problem. Okay, moving down to the next example. Example number 6. Determine the equation of the line perpendicular to the line AB. Perpendicular means we know the gradients. The gradients aren't equal, but we can, we know the relationship. And then the first thing I would do is you've got to flag the fact that perpendicular line. So the first thing I would work out is the gradient from A to B minus 3 minus 1 minus 1 but that means that the gradient swap it around and change the sign. Now, any working at all, I would just give you the mark straight for there for realizing the relationship. So basically, these two grades, and from there, it's a really easy grade 9 question, really, because you just need to sub in the point. The only point that's on the line, you don't know that A or B is on the line, it's just don't communicate to that. So I would sub in this, which means I know my equation. That's pretty cool. Okay, determine the line of the equation parallel. Well, again, parallel lines, you just need to see the word parallel lines and that's got everything to do with grade. Parallel lines are the same grade. Because immediately I know that whatever line is negative half. Again, this is grade 9 again because you don't the point. For the y value, for the x value, and negative half times 2 is negative 1. And then I add 1 to both sides. So, in fact, that entire question then. So most important things, if lines are given perpendicular, there is a relationship between the gradients, and the relationship is the one is just the other back off and then parallel lines have the same gradient. Okay, so example number 8. Example number 8 says, can you determine the gradient of lines from the points? This is over 3 little straight. Okay, can we work out these gradients? 4 minus 4, now that raises 5 by 0. That means you grade. So what's going on here? Explain yourself. Basically what happens here is that the gradient of a graph to 0 there was no change. There we go. Clearly y is remaining, which is why there's no change in y. So those 2 points A and B would lie. I mean, negative 2, 3, and B would line up there at 1, 3. But basically it's a horizontal line. So this is a horizontal line, and all horizontal lines have a now what's happening is that you are not changing the value of x. So this is the vertical. This is 4, 3. Ask you that type of question in an exam, but don't worry if you ever do come across gradients that are 0 or undefined if you've drawn a vertical or a horizontal line. Okay, last question is in gradients is the idea of collinear. So what does collinear mean? Well, first of all, the prefix co means together, and linear means on a straight line. So basically, they're trying to get you to show that these 3 points are on a straight line. So basically, if I draw this, and I'm not particularly accurately, but they want you to show which would be around up there, and 1.5 there, all 4. Do this. Gradient and to show that they're equal. Now, normally equal gradients mean the lines are parallel. Now, these lines can't possibly be parallel because they're both going from A to B and B. They can't possibly be different lines because they share the B. So the only way for them to have the same gradients is if they are which is 1, 2, so it's 8. Look at that picture, it makes sense. Now I'll find the grade from B to C. You can actually do A to C, sharing matrix. I mean, at that point. So therefore, that to C, which would be except these would go through the same point. So therefore, so just maybe to write a note here, because sometimes I'll tell you they're collinear, and then you maybe have to work backwards to coordinate. The most important thing about collinear is you have the same gradient the whole way. And because you're doing the same thing, it couldn't possibly be parallel. Cool, now that's all the examples that I was going to do for class. So if you get to the end of that, you're doing well. And it means that we'll do some work on this in class when I'm practicing this. Okay, have a nice day.